Mr. Guthrie here, continuing to look at the gas laws, and actually this is the last gas law that I'm going to go over, which is the combined gas law. As you can kind of see by that equation, P1 times V1 divided by T1 equals P2 times V2 divided by T2. It's really kind of a conglomeration of all the gas laws we've done, hence the name combined gas law. So, in Boyle's law, we can kind of see the fact that it is right here. P1 times V1 equals P2 times V2. That's Boyle's law, if you would ignore those T2s. Charles' law, on the other hand, was pretty much ignoring pressure, and so it was just V1 over T1 and V2 over T2. And then whereas Gay-Lussac's law was P1 over T1 and P2 over V2. So we just kind of combined all of these terms together where they normally are, because they're always in this stage, to bring this up. So when it comes to having to know which to use, there's always a little memorization that will be involved here. You really should just memorize this, and that would help you with remembering really everything else that needs to be done. Well, let's go into the sample problem that we did in class the other day. So a sample of hydrogen gas occupies 6.025 liters at 33 degrees Celsius and 56.6 kilopascals. What will the volume be at 108 degrees Celsius and 91.25 kilopascals? Well, again, the first thing we always do is just simply write down what we have. So in the first instance, we are talking about this, that we have hydrogen gas that has 6.025 liters, 33 degrees Celsius, and 6.6 kilopascals. This is all at the same time. So let's go ahead and define those things. 6.025 liters. Well, that is a volume. V1 then would be 6.025 liters. My 33 degrees Celsius is a temperature. T1 is 33 degrees Celsius. But yes, remember, when we have temperature, we cannot use degrees Celsius. We need to convert that to Kelvin. So we know that if we take our degrees Celsius and add 273, that will convert it to Kelvin, and therefore our T1 will be 306 Kelvin. All right, and then I see that I have 56.6 kilopascals. That is a pressure, and that is my P1. All right. Well, then the problem goes on to say, what will the volume be? So we don't know what that volume is. We will be solving for that. We don't know. It says that the temperature then would be 108 degrees Celsius. So T2 equals 108 degrees Celsius. Again, we don't want degrees Celsius. We need that to be Kelvin. So we go ahead and add 273 to it, and we find that our T2 will end up being 381 Kelvin. And then it says that the pressure is also changed, and that pressure is 91.25 kPa. Alright, so we have kind of put all of those numbers out there. We know what they are: V1s, T1s, P1s, V2s, T2s, or P2s. Now we need to use the combined gas law equation, put these numbers into it, and go from there. So let's do that. So there's my equation: P1 times V1 divided by T1 equals P2 times V2 divided by T2. So let's go ahead and plug in the numbers again we had just defined previously. So my P1 was 56.6 kPa. That'll be multiplied by my V1, which was 6.025 liters. And that will be divided by my T1, which we found to be 306 Kelvin. Alright. Well, then I go ahead and I look and find that my P2 was going to be, not going to be, it is, 91.25 kPa. We don't know what the V2 is. That's what we're going to be solving for. And then we found that the T2 would be 381 Kelvin. All right, got a lot of numbers going on here. At this stage of the game, I would go ahead and simply just, well, simplify this. So let's go ahead and simplify the left side of this. 56.6 times 6.025 divided by 306 would give me 1.114. And we got to do the units. And our units are this: kPa times liters over Kelvin. Nothing canceled out there, so we just have to write it all as is. Alright, now to simplify the right side of this, we would take 91.25 and divide it by 381, and I would get 0.2395. And again, we have to deal with the fact that we have our units there, and so they don't simplify, so we just have kPa over Kelvin, and then that whole thing is multiplied by our V2. Now we're simplified. Now this is a much more simple problem now. This is solving for x, or basically again our V2. Let's go ahead and get a cleaner screen and go ahead and make that happen now. So there it is. All right, that's what we ended with there. 1.114 kPa times liters over Kelvin, equaling 0.2395 kilopascals divided by Kelvin, and that term multiplied by our second volume. All right, well, we don't want 0.2395 next to that V2. We want to get V2 by itself because we're solving for. So, of course, we will cancel it out by dividing. So on the bottom goes 0.2395. And again, we've got to do those units here. So it is kPa over K. And what we do on one side, we need to do on the other. So this whole term will be divided by that same thing, 0.2395 kPa over K. Alright, so before we simplify, let's take a look at our units here. Well, I guess if we look at the right side, we can simplify. This is the same as this, so all of that goes away, leaving us with simply our V2, which is good. That's what we want to find. We do need to do some canceling of units on the left side, though. I can see that I have my kPa here, and that cancels out with that kPa. And then I have my kelvins, which also cancel out, leaving me just with liters. And so now I need to go ahead and do the math, which is just taking my 1.114 and dividing it by 0.2395, and I get 4.65 liters. And there it is. That is the final answer. That is correct, and we are good to go and have figured it all out. Again, if you have any questions, please make sure to email me, comment to this. I will get that and get back to you as soon as I can.